So homework questions. Yeah, 27. So let's go to 27. 27, I think, is up here. So x equals 1 plus cosine theta, y equals 1 plus 2 sine theta. So, can you read it again? X equals 1 plus cosine theta. Y equals 1 plus 2 sine theta. I mean, the first part it says you're going to make a graph, right? And what is the parameter of this graph? What do we mean by parameter? Come on, the whole lesson is about parametric equations. See, it's an example of how you just like process stuff. Oh, put that in front of me and I'll do that with it. But don't ask me what it's about, right? Which means you really didn't learn anything. What is the parameter? Parameter is the variable that both x and y depend on. What's the variable? Theta. Cosine is not a variable. Theta is a variable, right? So we would make ourselves a table of values. And actually, I need 3 columns, right? I'm going to have a column for the theta, I have a column for the x, and a column for the y. And, you know, what values should I plug in for theta? Remember, you get to pick the values, but, you know, understanding the way these functions work, it really wouldn't make much sense to do more than 0 to 2 pi and to pick some values in the middle, right? Because it's just going to repeat itself after that. So maybe at the very least, like we could pick the 4 or 5 values, right? 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, and then we'll plug into each one and see what we get. Right, if I plug in 0 here, then the cosine of 0 is, come on, unit circle time. The x-coordinate here is 1. So this is 1 plus 1, 2. If I plug in a 0 here, the sine of 0 is 1. The sine of 0 is 0, so this is just 1. Okay, pi over 2. The cosine of pi over 2 is 0, so this is 1. And the sine of pi over 2 is 1, so that's 1 plus 2, 3. Pi. Cosine of pi is negative 1. Negative 1 plus 1 is 0. The sine of pi is 0, so that gives us a 1. 3 pi over 2. Cosine is 0, so that gives us a 1. The sine is negative 1, so 1 minus 2 is negative 1. And then we're back to 2 pi, which should be the same as that, 2 and 1. Right, and so we can sketch that as a graph. All we're doing are the x and the y values, and it looks like our x's go from 0 to 2, and our y's go from negative 1 to 3. So 0, 1, 2, negative 1, 1, 2, 3. So plot these points. 2, 1, 2, 1, 1, 3, 0, 1, 1, negative 1, and 2, 1. Now, with those 4 points, are we sure what the shape is? You know, we did a problem kind of like this. All we really did was eliminate the parameter, but the shape ended up being a conic section. I think it was a circle. Right? So we could probably expect this as one of our conic sections. Could it be a circle? Let's see. It would be 2 across and 3 up and down, so that wouldn't be a circle, right? Could we imagine a hyperbola with 2 branches that somehow covered all these points? No. How about a parabola? Probably not. You know, parabola might hit these 3 points, but then what do you do with that? I'm guessing it's probably an ellipse, right? So probably the shape looks like this. Now, if you remember how we eliminated the parameter on this one, which was the second part, you know, what we did is we isolated the sine and the cosine, and then we squared them, and then we added the equation, because then you got sine squared plus cosine squared. And what does sine squared plus cosine squared equal? 1. So that's the strategy. Just in this case, we got a little more to deal with. In this case, when I solve for the cosine, right, the cosine will be x minus 1, right? And when I square it, I'll get cosine squared theta equals x minus 1 squared, right? When I solve for the sine theta will be y minus 1 divided by 2. And when I square it, I'll get sine squared equals y minus 1 squared over 4. And now if I add these two equations up, right, the sine squared plus cosine squared is 1, so there's no more theta, no more parameter, right? It's all x's and y's. And then here's the x term is going to be x minus 1 squared plus y minus 1 squared over 4 equals 1. So it is an ellipse. Right? It's an ellipse which has a center at 1, 1. The a squared is 4, so a is 2. So from there we go up 2 and down 2. The b squared is 1, so b is 1. Left 1, right 1. That's it. Okay. So which else? Yeah. 19? 19. Okay. 19 is it still on this page? Yes. 19. There's parametric equations. And this, they don't tell us the domain, do they? You know, you have to just figure out what the domain is. Meaning, for example, if you looked at, well, no, there is a little bit of a domain issue right here, isn't there? Because there, you could end up dividing by 0. So you have to say t does not equal negative 1. But it just depends. Like on this one, it wouldn't have mattered. You could have plugged in anything for t. So you just have to pick some points. So let's see, x equals t plus 1. Isn't this the one we did in class? Looks kind of similar to the example that we did. But we'll do it again anyways. Okay. T plus 1, t over t plus 1. Okay, so now we're going to set up our table of values. And the only point we can't plug in is negative 1. So we should probably pick a few points on either side of negative 1. I mean, again, negative 1, t equals negative 1 is probably some kind of an asymptote to the graph. There's some point that it jumps over. But there might be something on either side of that. So let's see. If negative 1, how about I'll pick a few points on either side? How about negative 4, negative 3, negative 2? And greater than negative 1, how about 0, 1, and 2? And now, if I put in a negative 4 here, I'm going to get negative 3. I'm going to just go negative 2, negative 1, 1, 2, 3. Okay. Excuse me. Negative 4 over negative 4 plus 1 is negative 4 over negative 3, which is 4/3. You know what? There's one thing we forgot about here. What did I forget to add to that? Arrows, right? Remember that these are, you know, that's the graph of an ellipse that we would have graphed if we had that equation to graph, right? but we didn't. We had parametric equations, and parametric equations are drawn as the parameter increases. So the first point we graphed was 2, 1, which is right here. And so we were going around in that direction. We should have added that in. I should have added that in. So it's not complete. Parametric equations, not complete without the arrows. Okay. So back to this. Okay, at -3, we're at -3 over 2, so that's positive 3 halves. At -2, we're at -2 over -1, which is 2. At 0, we are at 0. At 1, we're at 1/2. And at 2, we're at 2/3. So sketch the graph. So our x values go from -3 to 3. Our y values go from 0 to 4/3. Okay, so plot the points. -3, 4/3. -2, 3 halves. -1, 2. Okay, and then I jump down at 0. It's 1, 0. 2, 1/2. And 3, 2/3. 3, 2/3. And we know that there's a discontinuity at t equals -1, we get a problem with our graph here, which means the graph is going to jump. And if you graph this in a calculator, what you're going to see is it's actually 2 branches. This one is doing this kind of thing. And this one is doing this kind of thing. Now, we drew those points. I shouldn't have done that. In this order. But I drew these points like this. And I drew this point like this. So that's the plane curve. And it's jumping over. It's 2 pieces because that t equals 0 is acting like an asymptote. So it's creating an asymptote in the graph. Okay, now how are we going to eliminate the parameter? What do you do to eliminate the parameter? Yeah, solve one for the parameter, plug it into the other. I think in this case, probably pretty easy to see which one you'd want to solve, right? Yeah, the first one, if we solve that, it'll be t equals x minus 1. And then we'll plug in for x minus 1 here and here. Right, so this equals x minus 1 divided by x minus 1 plus 1. So y equals x minus 1 over x. Right? And you can see at this graph, because we're dividing by x, that means we should have an asymptote on the y-axis, and we do. You have a 0 of the numerator, which is a 0 of the fraction. It's 1, so it has a 0 of 1. So that makes sense. And it actually has another thing that we've done. It has a horizontal asymptote. What's the horizontal asymptote? Remember, when it's the same power, 1 and 1, it's the ratio of the coefficients, y equals 1. So this graph not only has this vertical asymptote, it has a horizontal asymptote here. Each one of these is going to approach that as x becomes large. Okay, any of the others? Right, so you have to, there is a question on the test graph, right? So you need to make a table of values, got to have t, x, and y. You pick the t's, calculate the x's and the y's, graph. Right? Make sure to use the arrows. And I think there's a different one, which is eliminate the parameter. Solve for the parameter, plug it into the other. Unless it's one of those trig, then you're trying to get a sine squared plus cosine squared scenario. Any other questions on homework? Okay, let me do this. Okay, quiet, please. Quiet, please. Okay, we're going to go over homework. Questions? No questions. Okay, let's move on. Yeah. Okay. Where's our 10-6 slides? 10-6. No. 10-6 slides. So here's the example we did in class. Right? When you got sines and cosines involved, right, you try to isolate the sines and the cosines so that you can square them and then add them up, right? Because what is sine squared plus cosine squared? 1, okay? That's the strategy, right? We did one exactly like it in class. So let's see, we go to number 20, start with 23, right? So how would you isolate the sine and the cosine there? Divide by 4, divide by 2, right? So let's do that. So that was 4 cosine and 2 sine. So this is 23. X equals 4 cosine theta. Y equals 3 sine theta. Right? X over 4 equals cosine theta. Y over 3 equals sine theta. Right? X, was it, did I copy it wrong? 2. Okay, sorry. So that one right there was a 2. So that was 2 and 2. Okay, so x squared over 4, no, so x squared over 16 equals cosine squared. Y squared over 4 equals sine squared. Right? Add them up. Right? X squared over 16 plus y squared over 4 equals sine squared plus cosine squared equals 1. Right? So if you looked at the other one, 27, what would you have to do to isolate the cosine in this one? Subtract 1, right? How would you isolate the sine in this one? Subtract 1 and divide by 2, okay? And then you're just doing the same thing. Now that one I did already. I'm recording these because so many people are gone. In the last block, right? So subtract 1, subtract 1 and divide by 2, square this one, square that one, and square that one to get this and this. And then when you add them up, sine squared plus cosine squared is the 1, and this one plus this one is that. Now, that wasn't all of the problem, right? The rest of the problem was you're supposed to graph a plane curve. So if you have to graph, you got to draw a table of values. Okay, you got to draw a table of values. Show the parameter, which this case was theta, and what values would you plug in for theta? I mean, there's no point doing more than 0 to 2 pi because it's just going to repeat itself after that. So, I did 0 to 2 pi and I put in every pi over 2 and just substitute it into those, calculate the x's, calculate the y's. Right, the first point on this graph was the point 2, 1, 2, 1. Right, the next point was 1, 3 up here. So you can see that the direction that it's being traced is here, is around like this. So plot all 4 points. This point is the same as this point. So just take it around the circle. Now this one was an ellipse, You should recognize that, right? The one that we just did here, what is that shape going to be? It's an ellipse, right? It's another ellipse. Right, so you can, again, make a table of values and put them in, but it's going to trace out an ellipse. We know what it's going to trace out. The only question now is, what's the direction of the arrows going around? Which other ones? Anybody? Yeah. 11? Okay. So let's do 11. 11 is, I think, over here. So we are tracing out a graph, and then we're eliminating the parameter. So this one will be x equals 1/4 t, y equals t squared. X equals 1/4 t, y equals t squared. Table of values. Do we have any domain issues here? Anything that might lead to a undefined? No? So you can pick whatever you want here. I think I'll do t, x, y. I get to pick the t value, so whatever you want. I think I'm going to do -4, -3, -2, -1, 0, 1, 2, 3, 4, which is a lot of points. But I know when I put in the -4 here, right, I'm going to get -4/4, which is -1, so that is -1. Right. For the -3, it'll be -3/4, -2/4, and -1/4. And 0, and then it'll all be positive. 1/4, 1/2, 3/4, and 1. Right, then we can put in for the -4 here. We're going to get 16, 9, 4, 1, and 0. 1, 4, 9, 16. So now we can sketch this graph. So we need our x values to go from -1 to 1, and our y values to go from 0 to 16. So that'll be my -1. That'll be my +1. This can be 5, 10, 15. Just to estimate here. -1, 16. -3/4, 9. -1/2, 4. -1/4, 1. And 0. And then the others are all reflections, right? So that'll be about there. This one will be about there. This one will be about there. So the first value was here, and as we increase t, then the graph went like that. That's it. And then eliminate the parameter. How will we eliminate this parameter? What do you do to eliminate parameter? First step. Solve one equation for t, right? So which one is probably the best? Probably the x. I mean, one thing we saw in the when we did the lesson, that if you solve this one for t, and then you plug it into the other, now you got more of a problem because you got to solve for y in the end. It's in a rectangular equation, you probably want to have it solved for y. So it's best if you can do that one, because at least it will already be solved for y. Right? So we do this one, it'll tell us that t equals 4x. So y equals 4x squared. Y equals 16x squared. So does that look good? So you put in x equals 1, y equals 16. X equals negative 1, y equals 16, which is what we got. We did another one, which was this one. I think this was 19. If you wanted to see it. I mean, this one is a little different in that I thought I had done the rest of that. Okay, we'll do our, I think what happened is this thing wasn't saved, and I just had to reboot the computer. So there's something missing from here. Don't have the eliminate the parameter part on there, but we could do that part. Plug in your values of t. Are there any values of t that we cannot plug in here? You can't do -1 because it would lead to a undefined for y, right? So I didn't put -1 in there. I picked 3 values that were less than that and 3 values that were more than that, and I calculated these x's and y's. And when I graphed those, the first 3 points, -3 4/3, that's this point. The next point was -2 3/2, -1 2. So they definitely went in this direction, right? And then the next 3. 1, 2, 3 for x, 0, 1/2, 2/3. 0, 1/2, 2/3. So what does it look like going on there? It looks like, at the very least, it looks like there's an asymptote. Because of that t equals 0, there's an asymptote right there. And there's actually something more than that. And we can figure that out if we just, let's eliminate the parameter. So let's solve this one. The first one, let's solve for t. Right? T equals x minus 1. Right? Then I'll come down here and say y equals t minus, oh, that was wrong. Edit, undo. Edit, undo, edit, undo. T equals x minus 1 divided by x minus 1 plus 1. Right, so y equals x minus 1 over x. So yeah, this has a vertical asymptote, x equals 0. Can't divide by that. That's why it looks like it's approaching the y-axis like an asymptote, because it is an asymptote. But more than that, what about the horizontal asymptote? Remember the rules for finding a horizontal asymptote have to do with the degree of the numerator and denominator. What's the horizontal asymptote when they have the same degree? It's the ratio of the coefficients. Y equals 1 over 1. So there's actually a horizontal asymptote right there too. Okay. So if you graph this, you would get that graph, but you wouldn't have the arrows on it. Right? You got to have the arrows. That's what makes it a plane curve, the graph of parametric equations. Any others we need to see? Anybody? Okay. So let me stop that recording.